Okay, so this second part of this video picks up where the first one left off. I'll scroll back up for a second, but you can see that we were talking about resistance, and at the end of the last one, the symbol R, the unit ohm, and it's the property that wants to slow down the current. So it's gonna, if you increase the resistance of a circuit, you're going to end up slowing down the current of the circuit, assuming you keep the voltage the same on that particular circuit. And that led us to Ohm's law, which you can see at the bottom. And Ohm's law, of course, will be something that we are going to end up using a lot in circuit analysis. So where I left off is this part where I just wanted to remind you that to determine the total resistance of a circuit, it depends on the type of circuit that you have. If you have a series circuit, which is where every item, of course, is connected one right after the other, in that situation, you're going to end up just adding your resistances together and getting your total resistance just by the sum of the three. So the more resistors you add, the higher the resistance is going to get in this circuit, and the less the current is going to get coming out of the battery. In a parallel circuit, to find the total resistance, of course, you do the sum of 1 over the resistances, and then you take the inverse of that answer to figure out your total resistance. So what ends up happening with a parallel circuit, the more resistors you add into that circuit, the lower the resistance gets and the more current you can draw out of the battery. And so that ends up becoming a problem over time. If you add more and more resistance, you could potentially cause a situation where the current got too high, and that could cause an electrical fire. So what you would do with a circuit like this is, if you're concerned about the current getting too high, you would just put in a little fuse or a circuit breaker or something right here at the beginning, so that it shuts off the circuit if the current gets too high. All right. So just to remind you how to analyze circuits, the first thing, of course, you need to do is draw the circuit out. You want to find the equivalent resistance of the entire circuit, so you're going to need to do the parallel parts first, and then add all the series up. Then you're going to want to find the total current coming out of the battery, which is going to be the total voltage divided by the total resistance. And I didn't say this on the previous slide, but this EQ means equivalent resistance. I think last year we used R-tot. Well, this is, it's just equivalent resistance. So you're going to take your total voltage, divide by your total resistance, and that'll get you your total current. And then your total current could also be the EMF, that's that EMF, divided by your total resistance, if you happen to have to include an internal resistance for the battery. So if you see that happening, you just have to include that in there. Then you can find your individual voltages and your individual currents using Ohm's law again, but you have to kind of keep up with the rules. Remember that, let's see what's on the next slide. Yeah, we'll go back for a second. Remember that in series, when you have a series circuit, remember that the voltages all add up. So all the individual voltages add to the total, but in parallel, the voltages are all the same. And then in series, the current is the same. They all get the same current going through them, but in parallel, the currents add up together to give you the total current. So you kind of have to keep those rules in mind as you're doing this. So we're going to do a couple of examples together, and so that you can kind of review this all in your head. So the first one, two 100 ohm resistors are connected in parallel. So we're going to do part A, in parallel to a 24 volt battery. So we'll do it in series. They want to know what's the current through each, what's the equivalent resistor of each, and they want you to draw the roller coaster for this circuit. So let's go through that. We're going to draw it out first. Two 100 ohm resistors connected to a 24 volt battery in parallel. So here's one of them, 100 ohms, and then the second one is in parallel, 100 ohms. Let me bring that back together, and that's my circuit. So I've drawn out the circuit. The first thing I want to do is I want to find the total resistance of this. So 1 over 100 plus 1 over 100 equals 1 over R equivalent, or R total, and that gives me 2 over 100 is 1 over R equivalent, which makes R equivalent 100 over 2, if I flip that over, which is 50 ohms. So these two resistors can be replaced by a 50 ohm resistor. So if I redrew this circuit, that's an equivalent circuit, what I just drew here on the right. That's an equivalent circuit to the first one. The total current, the next thing you're going to want to do is find the total current. So the total current in this circuit is total voltage divided by total resistance. So 24 volts divided by 50 ohms gives me my total current. And in this case, my total current is 0.48 amps. So that's what you end up getting right here. 0.48 amps is coming out of the battery. Now, that means over here, 0.48 amps is coming out of the battery. Now, this current is going to split, and in this case, it is going to split evenly because those two resistors are even. It doesn't have to split evenly, though, if those two aren't equal to each other. If you wanted to find the current of each of these, you could do it a couple of ways. One of them is you have to recognize that each of these has 24 volts on it because it's in parallel, and it's the only thing in the circuit. They're each going to have 24 volts across them. So each individual current is going to be each individual voltage divided by each individual resistance. So that's going to be 24 divided by 100, which is 2.24 amps. So each of these has 0.24 amps going through it, which together add to give you your 0.48 of total current. So that's how this circuit ends up getting analyzed. If we were to draw the roller coaster for this, the circuit kind of looks like this. You have your battery, and then you have your split, your 100 and 100 split. The electron leaves the battery with 24 volts of potential. He needs to drop all that potential before he gets through the circuit. The first thing he encounters is this split, and he either goes one way or the other way, but he only has one option, so he goes one or the other. He has two options, but he only takes one option of one of those two. So either way, he's going to drop all 24 volts in that one little section of the circuit, and that's it. That's my total circuit. So that's part A, where the two resistors are put in parallel. For part B, if my two resistors are put in series, that circuit is going to look different. It'll have 100 and 100 together, which will give me 200 ohms of total resistance. So my R total, or my R equivalent, is 200 ohms. That means my I total is going to be 24 volts divided by 200 ohms. 24 volts divided by 200 ohms is 0.12 amps. So that 0.12 amps is going to come out of the battery. It's going to travel entirely through the first resistor and entirely through the second resistor. So each individual current is going to be 0.12 amps. So what that means, each individual voltage is going to be 100 times 0.12, and that's going to be 12 volts. So each of these has 12 volts across it, which leads me to my total of 24. So if I draw the resistor, the roller coaster for this circuit, the electron's going to leave the circuit again, leave the battery, pardon me, with 24 volts of potential that he needs to drop. He's going to drop half of it in the first resistor and half of it in the second resistor. And that's going to be my roller coaster for this particular circuit. Okay, which leads me to my next problem. How much current is drawn from a battery in the circuit that's shown below? You have the circuit, I don't, so I'm going to draw it real quick. It's a 12 volt battery, a 400 ohm resistor that is in series to a 500 ohm and a 700 ohm that are in parallel with each other. Okay, and for this particular circuit, they want to know how much current comes from the battery, so that's I total. They're interested in that, and they want to know the current just through this top branch right here. So the first thing I need to do is find R total. So I'm going to do the parallel part first. 1 over 500 plus 1 over 700 equals 1 over the R parallel. You end up getting a parallel resistance when you do that of 291.7. R parallel 291.7. So this entire section, if I redraw this, I could redraw it over here to the side. The 400 is right here, and that entire parallel I can replace with 291.7. And that's going to give me my same circuit. So those are equivalent circuits. I can then add these two together to get 691.7 ohms as my R total for my entire circuit. So 400 plus the 291. So I have my R total, which means I can now find my I total. My I total is 12 divided by my R total, 691.7 ohms. So that's going to give me 0.0173 amps of current coming out of the battery. So if I label that here, 0.0173 amps. That entire 0.0173 is going to travel through the 400. Okay? And then, so what I can do, so I need to figure out the voltage on this so that I can figure out how much current goes through this branch. So I can do that a couple of ways, but the way I've chosen to do it is to figure out the voltage here, I'll call it V1, and subtract it from 12, and then the remaining voltage is going to be the voltage on this section right here. So I'm going to find V1 by doing 0.0173 times 400. That gives me 6.92 volts just for this section. Just for the 400 ohms, 6.92 volts. If I subtract that from 12, that leaves me 5.08 volts left over. So that remaining 5 volts of potential has to be dropped either up here or down there, which means each of these is 5.08 volts, since voltages in parallel are equal to each other. So 6.92 plus the 5.08 here gives me my 12 total. So that means the current in the 500 ohm resistor is going to be 5.08 divided by 500, which is 0.01016 amps, the current just in that 500 ohm resistor. Okay, so that's how we work this particular problem. There's a couple of different ways you could have done it. You could have, for example, done the current 0.0173 amps times the 291, and that would have gotten you also the 5.08. So you can do it a couple of different ways, but this is the way I chose. All right, there's one more problem for you. It says, I'm going to draw it out for you, and then I'm going to give you the answers and see if you can get those. A 9-volt battery whose internal resistance, so it's a 9-volt battery with a little half ohm resistor, which you're just going to treat as part of your circuit, is connected to the circuit that's shown. So you have 10 ohms up top, 6 ohms right here, and then 8 ohms and 4 ohms right there in parallel with each other, and then back together, and then 5 ohms over here in series. And I want you to figure out the terminal voltage of the battery. So you need to know the I, the current of the battery, in order to do that. And so in order to do this, you need to figure out the total resistance. So you're going to start by doing these two together. Those two together in parallel give you a 2.67 ohms. So you got to figure that out. 1 over 8 plus 1 over 4, blah, blah, blah. Do that part. That's 2.67 ohms. You're going to add that to 6. So now, when you add these two together, 2.67 and 6, you get a total resistance down on the bottom of 8.67 ohms. So that's your bottom together. Now you're going to do the parallel of these two. The 10, 1 over 10, and 1 over 8.67. You're going to do those together, and you're going to end up getting 4.64. So all of this stuff right here is 4.64 ohms. Then you're going to take that 4.64, add it to 5, and add it to the half, the 0.5. You're going to add all of those together to get 10.14 ohms. That's your total resistance for your whole circuit. 10.14 ohms for the whole thing. That means that your I total is going to be 9 divided by 10.14, which is 0.89 amps. Once you have your I total, you can find your terminal voltage, which is